Lesson 3.7 is trapezoids. Let's take a look at some properties of trapezoids. First, we have a non-isosceles trapezoid. We would typically just call that a trapezoid. You wouldn't say non-isosceles. So if I just say trapezoid, I can assume that I have one pair of opposite sides parallel. So in this diagram, these are parallel. The others are probably not. Consecutive angles are supplementary. It isn't all the way around the shape, though. It's only the ones that are part of the parallel lines cut by a transversal. So this angle and this angle are gonna be supplementary. And then over on the other side of the trapezoid, these guys have to also be supplementary. But you cannot assume the other pairs are supplementary, and they probably aren't. That's a parallelogram thing. So we have two sets of supplementary angles, and that is due to parallel lines cut by a transversal. Next, we're looking at a specific type of trapezoid, the isosceles trapezoid. An isosceles triangle has two congruent sides. We call them the legs. An isosceles trapezoid has two congruent sides, also called the legs. So our parallel sides are here. In an isosceles trapezoid, it is the non-parallel sides that are going to be congruent. So these two have to have the same length. Once you become an isosceles trapezoid, you now have extra special properties. First property is that the diagonals are congruent. So this guy here and this guy here have the same length. That's also a property of a rectangle. And that's why congruent diagonals alone isn't enough to prove something is a rectangle, because this guy has congruent diagonals and is obviously not a rectangle. Next property, like in an isosceles triangle, the base angles are congruent. So in this diagram, we have two sets of base angles because we actually have two bases. These are congruent. Those are base angles because that's a base. And these guys are congruent because those are also base angles. So if I have some vocab, this is base 1, this is base 2, and then the non-parallel sides are called the legs. The reason the vocab is so similar to isosceles triangle is because if you took an isosceles triangle and you chopped the top off, that shape that's left on the bottom is now your isosceles trapezoid. And so the base angles are still congruent. Now, when I chopped the top off, I didn't chop it off randomly. That green line that I just drew was parallel. I chopped it off parallel, which brings us to mid-segment of a trapezoid. The mid-segment of a trapezoid connects the midpoints. So in our diagram, AE is congruent to ED, BF is congruent to FC, because E and F are both midpoints. When I connect the midpoints, this segment right here is called the mid-segment. It's in the middle. It has some special properties. When I draw in that mid-segment, I know that it is also parallel to the sides of the trapezoid. So EF is parallel to AB, which is also parallel to CD. All three of these segments have to be parallel. Next property, this has to do with length. It's in the middle, right? So its length is in the middle. So EF is the average of AB and CD. So to calculate it would take half of AB plus CD. I'm averaging those two lengths to find the middle length, the length of the mid-segment. Let's look at some practice questions. Here I have a trapezoid. It's a trapezoid because I have these guys marked parallel. When parallel lines are cut by a transversal, consecutive interior angles are supplementary. So 12x plus 3 plus 13x plus 2 must equal 180, and then we would solve that for x. Next example, AB is 7y plus 6. EF, our mid-segment, is 5y minus 3. And DC is y minus 2. I will say this question should have had some more information given. I should have told you that E was a midpoint and F was a midpoint. So if those are midpoints, EF is a mid-segment, which means 5y minus 3 is the average of y minus 2 plus 7y plus 6. That's one way to calculate it. Or you could say 2 of those middle segments is equal to base 1 plus base 2. Both of those equations are going to lead you to a correct value for y. Number 3, this is an isosceles trapezoid. If it's isosceles, legs are congruent. Base angles are congruent. We have that EDO. I like to play connect the dots. EDO is 110. Because it's a trapezoid, those consecutive angles are supplementary, so I instantly know that my angle down here has to be 70. And that's actually the angle they give me. DEN is 15x minus 5. 15x minus 5 has to equal 70 because it's supplementary to the given angle. I could solve that for x. Here we have another isosceles trapezoid, which means legs are congruent, base angles are congruent, but most importantly for this question, it means that diagonals are congruent. And they tell me that PR is equal to 3x minus 7, TA is 20. Those are the two diagonals. So if I set them equal, I could solve for x. Please use this as a guide to help you practice the first part of homework 3.6.